and we're eager to hear more from you, dear Thomas. In planning this conference, we were guided by the Anthropocene concept with its complex processes from atmospheric changes to the acidification of ocean to urbanization and so on. We'll hear in a moment more on that. Hence, the conference is based on 5 guiding ideas deriving from the concept of the Anthropocene. First, to investigate the triad of anthropogenic impact on climate, the geophysical consequences of climate change, and the transformative impact of climate in different sectors, from society to politics, from agriculture to all our infrastructure. Second, to assess mitigation and adaptation approaches, strategies, solutions, conflicts, assistant instruments between national, supranational, and the regional level. And fifth and last, we might suggest innovative ways to increase climate literacy, transparency of decisions, and the acceptance of citizens and business for approaches towards climate neutrality. I'm very confident that the brainpower assembled here is ready to develop our ideas into a clear communiqué with maybe some influential recommendations. So I extend my gratitude to our strategic partners, the Polish Academy of Science, to the president, in particular Marek Konarzewski, and my wonderful friend Jerzy Duczynski. Last time I've seen you in this room, before that in Berlin, and Paweł Rowiński for hosting this wonderful meeting at this absolutely outstanding location here at the Polish Academy of Science in Warsaw. I thank from the Leopoldina the members who've contributed, in particular Thomas Stocker for giving the Crutzen Lecture, Jürgen Renn and Robert Schlögl for organizing. And all of this would not be possible without the outstanding Polish-German organization team led by Anna Lata-Zyberg from the Polish Academy and Lucian Buschan from the Leopoldina. I very much look forward to hopefully highly engaged discussions. Thank you very much.
Good afternoon, dear presidents, distinguished guests, dear colleagues. I'm also very happy that we managed to gather all these fantastic people with us here, and this discussion may be very fruitful that we are going to have. But this is my great pleasure now to say a few words, introductory words, before I would say intellectual and spiritual feast ahead of us, namely the Crutzen Anthropocene Distinguished Lecture. And Gerald took a bit of my job and told you a bit about Professor Crutzen, but nevertheless let me just mention a few words about him, though I believe most of you know Professor Crutzen very well. So this lecture series honors the Nobel Prize winning scientist, and Paul Crutzen is known for his work providing evidence of human impacts on the Earth, climate and environment, and for proposing a new geologic epoch known as the Anthropocene. And this is actually what will this talk be about, and our major part of our discussion will be about, to some extent, about Anthropocene. In 1995, Crutzen and his colleagues, Professor Molina and Professor Rowland, received the Nobel Prize for Chemistry in recognition of their work in protecting the ozone layer. And at this moment, I am proud to say that a few years ago, we had a chance to host here Professor Molina. I myself had this privilege to lead a discussion with Professor Molina in Copernicus Center. It was a public discussion on problems of climate change, because he switched very much towards climate change from ozone problems. And what was important about Professor Crutzen, he campaigned for a worldwide ban on all substances which are dangerous to the atmosphere and that protects the Earth. And the 1987 Montreal Protocol on substances that deplete this ozone layer, a global agreement to protect the stratospheric ozone layer by phasing out the production and consumption of ozone-depleting substances, was largely the result of his efforts. And in our community, we can say that this brings a bit of optimism in our discussion, because it was really successful, and hopefully we can have similar, or at least part of the success within this climate change campaign. And now let me introduce, and I treat it as a great privilege, our distinguished speaker, Thomas Stocker from University of Bern in Switzerland. It is obviously impossible to mention all his achievements. The list is too long for a short meeting. But obviously the analysis of ice cores from the polar regions, developing models of climate change, weather and climate forecasting are trademarks of his research activities. His publications may be found in most prestigious journals that deal with climate problems. Professor Stocker held research positions at University College London, McGill University in Montreal, Columbia University in New York, and University of Hawaii in Honolulu. Since 1993, as I mentioned, he is professor of climate and environmental physics at the University of Bern. Thomas Stocker has authored or co-authored more than 250 peer-reviewed papers in the area of climate dynamics and paleoclimate modeling and reconstruction. After more than 10 years of service in the United Nations Intergovernmental Panel on Climate Change, shortly IPCC, he was elected a co-chair of Working Group 1 of the IPCC for the period from 2008 to 2015. Thomas Stocker was awarded a Doctor Honoris Causa of the University of Versailles in 2006 and of ETH Zurich in 2016. He also received the Hans Oescheger Medal of the European Geosciences Union in 2009. And in 2017, he was the recipient of the Swiss Science Prize Marcel Benoit. It is often dubbed the Swiss Nobel Prize. So we have a Nobel Prize laureate here with us, which I am very happy to announce. Professor Stocker, during this Crutzen Anthropocene Distinguished Lecture, will share his views on the transition that humanity is facing now and in the near future when sliding into the Anthropocene, and we'll talk about surprises which are going to be ahead of us. So, Professor Stocker, it's my great pleasure. The floor is yours, and the stage is yours as well. So, thank you very much.
Thank you very much, and from my side, welcome. I'm very happy to be here in Warsaw and would like to thank the academies, both the Polish Academy of Science and the Leopoldina, for this visionary bilateral meeting here to hopefully accelerate climate change issues. And I'm particularly honored to be asked to give the Paul Crutzen Lecture, but it's also a big responsibility to essentially set the standard for what hopefully will become a series of lectures that would feature the latest, what we know about climate change and beyond, particularly the impacts and in particular the opportunities that lie ahead in tackling one of the greatest challenges of humankind. What I want to do today is to pay tribute to Paul Crutzen, a unique individual who has actually shown that science can make a difference. And if there is anything that you should take away from this lecture is a sense of enablement, of motivation that yes, we can tackle that problem, because there have been scientists in the past that have succeeded in tackling an important problem, but not as widespread a problem as we're talking about today, and that is climate change, but equally important. And the most important element is that they showed us the way how it could actually work. So Paul Crutzen, in 1995, I still remember, I've been around long enough to remember that memorable communiqué that announced that the three chemists and environmental scientists, Sherry Rowlands, Mario Molina, and Paul Crutzen were awarded the Nobel Prize in Chemistry in 1995. Why was it so memorable? Because it was for the first time that an environmental problem got attention by the Nobel Prize Committee. And for us working in this discipline, this was an extremely important message. It was the message that these problems have arrived at a level where usually only basic research is awarded. It is a basic problem, and that is the reason why the Nobel Prize in Chemistry was given. It's good to start with a quote by Paul Crutzen. Paul Crutzen has been very influential as a member of the Pontifical Academy in Rome, because he was, based on his authority and his success with tackling the ozone problem, in advising the Papal Academy on issuing a document in preparation of the Paris Agreement. I don't know whether many of us still remember. I find this one of the most remarkable documents that the leader of the Roman Catholic Church actually prepared or had prepared with a team of scientists, the encyclica Laudato Si, which was published early in 2015 and which was followed by at least 3 similar declarations by different creeds that all point to the same problem. And that is how humans actually behave on this planet, the only one that we have, our home. And I think it was remarkable because it was for the first time that a message did not come from science when it came to climate change. How warm, how different is the climate now from the past? But it came from religious leaders, which I think touched many individuals who did never listen to science, but have listened to other authorities in our society. And I think it was an important element to convince the leaders of the countries to actually stand behind. And finally, after more than 20 years at that COP21, to actually pass the Paris Agreement in consensus. A historical moment. I will come back to that. So Paul Crutzen, I deviated a bit, in his engagement with the Papal Academy in 2017 said, the notion of the Anthropocene, the age of humans, comes from the observation that humanity is it's a bit small. I thought I had sharp eyes, but my age is also compromising my view. Nature in shaping our present by profoundly changing the atmosphere, biosphere, land surface, and oceans. And the important point here is that he actually addresses every component of the climate system. Global warming and environmental pollution are also challenging issues of justice, because the poor and future generations are the ones most affected. I really appreciate that statement from a senior scientist and Nobel laureate, that he points in the problem of climate change, which often is considered a scientific problem only, that he touches upon these fundamental points, that it's the future generations that have to live with what we do today to our atmosphere, to our biosphere, to our oceans, and to all systems that in fact are life systems here on this planet. So in this article in 2000, that is an article that was actually motivated by a statement that Paul Crutzen made at a conference after having listened for quite a while to scientists telling about climate change in the past. And those who are paleoclimate scientists know that often we talk about the Holocene, the epoch where man has had a guaranteed stable climate in which agriculture could develop. It's called the Holocene. And Paul Crutzen, these anecdotes read that he was quite unnerved after having heard for the 10th time the Holocene, stood up and exclaimed that, well, you should be aware we are no longer in the Holocene, but we are. And a memorable pause followed. His brain was churning, and out came the notion of Anthropocene. Anthropogenic climate change was already a standing notion with the scientists who were looking at other aspects, but the Anthropocene as an epoch, which would mark a geological change in the stratigraphy of conditions that would be measurable in the far future by future generations that could see, yes, there was something fundamentally different to an undisturbed 10,000-year layer in our climate records. And I think that was a moment of genius that amalgamated a view on our epoch today as one that is influenced by human action. It's not a statement about good or bad, it's a statement of fact that we are changing our environment. A second notion in the context of the Anthropocene was motivated by this overview article a bit later, and that is the Great Acceleration. It's actually very easy to look at observations of different kinds. Take greenhouse gases, take the ozone depletion, take land use change, take the use of energy. All these curves show up in a way that indicate an acceleration of usage, an acceleration of waste, an acceleration of concentrations of substances in the atmosphere. And so this new notion, the Great Acceleration, is actually quite well used today when we talk about how to tackle that problem. The Great Acceleration has to be addressed and to be transformed to bend these curves of acceleration. His work, and one should mention his work and the work of many of his students and colleagues, led to an understanding, a fundamental understanding of how ozone in the stratosphere is depleted and what is responsible for that. Very complicated atmospheric chemistry. I will not go into that because I'm not an atmospheric chemist, but we also have no time tonight. But complex reactions and reaction kinetics that require a deep understanding which substances are responsible for what processes, led to an understanding and a communication to the policymakers that indeed we do have a problem. And in looking back, I often wonder, why was it so quickly adopted and accepted that we do have a problem with the ozone? I believe it's in the point that the ozone actually protects us from abundant UV radiation. And that directly goes into your health condition. People know about skin cancer. People know about the consequences of high doses of ultraviolet radiation. And I think that connection accelerated implementation of measures. That coincidence with the invention of substitute substances for the responsible constituents that accelerate the destruction of ozone in the stratosphere led to the Montreal Protocol in 1989. And that is a success story that should motivate us today to get strength in addressing climate change mitigation. The Montreal Protocol is in force since the 1st of January in 1989. It is a legally binding regulation, and it's the only one that is signed by all nations, 197 nations in total. And it also has a well-oiled machinery that guarantees monitoring. Monitoring means financial investment in infrastructure that allows us to quantify how these concentrations of various substances actually develop from year to year. And what is also unique in this agreement is that there is a sanction procedure at work. It's not that you arrest nations if they emit too much CFCs or other substances that are banned by the Montreal Protocol, but it's agreed by the parties that the parties need to abide by what they signed in the Montreal Protocol. And we have cases already now where big nations actually make payments to clean up and to transform and to close emission sources in their own countries. So it is a framework that does work, and may I say, we need such a framework for the other substances that give us big trouble. That is the greenhouse gases. An important element is quantification. If we talk about global change, we need to quantify. When they talked about the ozone problem, they quantified immediately. There were 100-year records on a total ozone column concentration. And you see here, for example, for October in the southern hemisphere over Antarctica, the total ozone concentration, how it dropped towards the end of the 1980s and then recovered. The recovery, a sign and a message of success for the Montreal Protocol. Although it will take longer for that recovery than expected, it is on the right track. We are on track in protecting the ozone layer. We're not on track protecting our atmosphere from climate change. Let's go back a little bit more to take now sort of a chronology of events, starting with this article, The Origin of Ozone in the Troposphere. And one thing you should notice here, Paul Crutzen was also interested in pollution, the formation of ozone in the troposphere. That's actually why he got the Nobel Prize in chemistry. Not for the depletion, that was the other two colleagues, but for the formation, understanding how ozone is formed, that has a direct consequence to understand the pollution of the troposphere. The troposphere being the lowest 8 kilometers in which we live, and which we pollute through our industrial activities, and that problem was recognized by Paul Crutzen in 1978. Now, I didn't choose that article by chance. There is a very important year, 1978, for another problem that few scientists already have identified in 1978. You see here the picture of Charles Keeling, who since 1958 meticulously and with the absolute highest precision driven. It was a passion of him. I had the privilege to actually meet him several times. He spent a sabbatical also at the University of Bern. Meticulously the concentration of carbon dioxide, the most important greenhouse gas in the atmosphere after water vapor, and the most important human-created greenhouse gas in the atmosphere. Around these years, in fact, he was told by his funders, the National Science Foundation, well, Dr. Keeling, your measurements are brilliant, we congratulate you, but, you know, what do we learn? We know, actually, how this curve will continue. What do we learn? And a few visionary colleagues actually intervened, and we should owe them a great thanks and gratitude that this time series since 1958, although at that time it had the touch of monitoring, has been continued without interruption. 1978 was also a year when two of my former colleagues at the University of Bern published this paper, predicting future atmospheric carbon dioxide levels. Seems like many years ago, 1978. What did they say? They say in that paper that was published in Science, a time when global warming was only in the heads of a few scientists who were well informed and who had the ability to look forward, to see what's coming. They said the maximum permissible CO2 level might be found which should not be exceeded in the atmosphere if the atmospheric radiation balance is not to be disturbed in a dangerous way. These were very courageous scientists because they were using emotional words. We were told when I started in IP, a scientist actually pointed to the problem, the potential problem of warming due to the emission of fossil fuels, 1938. And in the meantime, this curve goes up and up. You could say this is the great acceleration. If I look at it from a scientific point of view, I see the beauty of the precision of these measurements by showing us the breathing of the vegetation. These are the small yearly cycles of carbon dioxide, but the exponential growth with a positive curvature still in there, meaning an acceleration, is the disturbing fact of this time series, the Keeling curve. In spite of 6 successive assessment reports, 6 times belabored consensus of the scientists, approval of statements by the governments, we could not yet break that curve and that trend. And that is actually quite depressing. But think about the Montreal Protocol. Now the problem is more gigantic than that. Man has changed the atmosphere in profound manner. Early when the Keeling curve was published, some people said, well, it's just part of a natural fluctuations. That will go away by time. But we look further back. We look into the Holocene, but we also look much further back than the Holocene. And we do that by taking these ice samples from Antarctica. You see here little white speckles. These are bubbles. The bubbles contain air entrapped a long time ago, and together with the air, nitrogen, oxygen, there are also the greenhouse gases, CO2, methane, N2O, and many other substances. We measure these. These are more than a dozen PhD theses that have gone into the development of the analytical method, into the measurement of 800,000 years of climate history from an ice core from Antarctica. You see here the CO2 concentration, and yes, the CO2 concentration has never been constant. You see wiggles going up and down over the last 800,000 years. If you blur your eyes a little bit, you can identify more or less 8 complete cycles of high values, low values. These are the ice age cycles. Natural fluctuations. The climate system responds, but is also being driven by carbon dioxide in the atmosphere. But what happened in the last 250 years is remarkable. Through the burning of fossil fuel, coal, gas, petrol, and deforestation, we have managed to bring the system totally out of whack. You see here these concentrations at over 420 ppm, a value that has never been achieved in the last 800,000 years. This is a scientific fact, no longer contested by anyone. This is a fact. Now, what does that leave us with? It leaves us with a very simple statement that we made in 2013. Human influence on the climate system is clear, full stop. You may say, oh, this is a statement that I read in the media, or that is said on TV. No, it's a statement that you find in the summary for policymakers in 2013's IPCC assessment report. It's a statement that 193 countries made in consensus. Human influence on the climate system is clear. By the way, during a time when the climate skeptics had high tide because they claimed that we were living in the climate pause, I was asked constantly, Professor Stocker, when do you admit that climate warming has stopped? Based on a cursory look on the global mean temperature curve of the previous 10 years. Okay. Human influence on the climate system is clear, but then the more important question follows immediately. What is the future? And that future is summarized here in this complicated graph, but it's a premiere for IPCC in bringing together proxy data, indirect data of how our climate system was 60 million years ago until now, direct measurements, last 100 years, and projections using coupled climate models for the next 200 years. And if you go down the time axis from left to right, you are on a travel on top, CO2 concentration, that most important greenhouse gas after water vapor, and global mean temperature anomaly. In the middle, you see the Earth temperature anomaly from a very hot Earth in the early Eocene, about 30 million years ago, to present, pale colors, into the future. The future, of course, rendered in various scenarios. A scenario means that we have a choice. We have a choice of protecting the climate system or of doing business as usual. Now, the business as usual you see in the top color map on the right. That is the temperature anomaly or the warming in the year 2300, estimated by a dozen or so climate models, assuming that carbon dioxide concentration increases with no limit. That is, the emissions will continue with all the countries coming on board of being large emitters. This is a scenario that brings us into a temperature that the Earth hasn't seen for the last 30 million years. And it does so, you could say, well, okay, yeah, that was a temperature 30 million years ago, so the Earth can handle that. But you need to recognize that we complete this change in less than 200 years. An absolute mind-boggling speed to which everything on this planet would have to adapt. Insects will adapt, ecosystems may adapt, many will not be able to adapt, and humans are probably those who have the hardest time to adapt to that. So in fact, that's really a scenario of no choice. The other scenario that you see is the lowest scenario, that is the scenario compatible, just barely, with the Paris Agreement. These pale colors mean that there will be warming, particularly in the high latitudes of our planet, which has specific consequences that cannot be downplayed, but it's a world where in most places we can adapt. But some changes will actually be ahead of us, changes that may actually be irreversible, like the meltdown or the partial melting of the Greenland ice sheet. Show here some recent simulations that we carried out. 1 times CO2, Greenland as you know it, 1.3 times CO2. This is admittedly a sensitive model, but it's the steady state under 1.3 times pre-industrial CO2 concentrations in about 3,000 years from now. That is in equilibrium climate at that concentration. And you see some ice has been lost in the southern part. A lot of ice will have been lost at 1.5 times CO2. About what we have today, but if that condition lasts for another couple of thousand years. And that's not really what we aim with the Paris Agreement. A second thing that can happen in unabated climate is the risk of tipping points, thresholds that may be crossed. And you see here a summary of those that are known today. There is still a lot of debate going on in the scientific community whether or not these elements will actually tip and where. But one thing we know, there are credible physical models that for each of these elements show that nonlinear processes are in principle possible to tip these processes. And the third point that we need to reckon with are so-called high-impact, low-likelihood events. And they are much more pervasive because they act on the regional level. It was mentioned in your introduction, regional climate change is under-researched and under-understood. We don't really know much about when it comes to quantifying what regional climate change means, in particular, the regional climate change associated with the water cycle, precipitation, water resources, etc. And you see there different processes that are mentioned, unexpected high levels of climate change, for example, heat waves, unprecedented weather extremes, climate tipping point I've mentioned, or other unexpected human action and reactions on climate change. What that all means is much more than degrees Celsius and millimeter per year of sea level rise. In fact, the likelihood of abrupt and irreversible changes and their impacts increases with higher global warming levels, a statement of the last synthesis report. And another statement in that report goes directly to the Paris Agreement. It says the level of greenhouse gas emissions reductions this decade largely determines whether warming can be limited to 1.5 or 2 degrees Celsius. The key information here, this decade. We don't have a lot of time. This decade determines whether the Paris Agreement will be successful or not. And as I said, the Paris Agreement is a historical achievement. We can all be proud of that, but it's only the first step towards reduction of global CO2 emissions and reaching net zero in the second half of this century. And that's how we fare. These are the latest numbers on the global emissions by the Global Carbon Project, and you see that essentially this curve goes up. And as this curve goes up, the carbon dioxide concentration in the atmosphere keeps accumulating. It doesn't go away. It's not an open bathtub in which you just reduce the faucet a little bit and then the level goes down. It accumulates, and therefore that is the reason why we must go to net zero. That's what we have to achieve. This is a very difficult task, but it's not impossible. Zero CO2 emissions. How much time do we have? The science responds to that question thanks to the global carbon budget that was brought to the policymakers after a long struggle in 2013 in September at that plenary session. We had to work day and night until the last country was prepared to approve that concept in consensus. There was some quite stubborn resistance to that concept for obvious reasons, but we did it, and it's now uncontested. This has entered the policy maker arena. It's actually an instrument to quantify how urgent the problem is. For the 1.5 degrees Celsius, our budget that remains is at around 280 billion tons of carbon, which at current emissions, if they don't go down, leave us about 7 years, and then that budget is exhausted. Or if you want to go down exponentially, smoothly towards net zero, you must reduce your emissions, global emissions, every year by 14%. Now I leave it to you to ponder whether that is possible or not. The 2 degrees Celsius target, warming below 2 degrees Celsius relative to pre-industrial, is less ambitious. We have a remaining budget of 1,030 gigatons of carbon, which would leave us at current emissions constant 27 years until exhaustion, or a rate of minus 3.7% every year. The first few years may be easy. The next few years, a little bit more difficult. But then it gets really hard if you haven't done your homework, if you haven't prepared your technologies, if you haven't fitted your infrastructure, if you haven't taken political decisions to a different framework of, for example, carbon pricing, etc., etc. These are the bare numbers based on the global carbon budget. Nothing political, it's simple algebra and a little bit of understanding of the exponential function, which every banker understands damn well. There is another issue here, and that goes far beyond the physical aspects of climate change. And that's the last point I want to make. The climate crisis is actually a resource crisis. It's less abstract than degrees Celsius in global mean. Who can imagine that? Who cares? We care about resources. For example, when you have global heating, we've known that already since 2003, the legendary European heat wave that caused 70,000 premature deaths of vulnerable parts of the society. That affects the resource of health. It's not a coincidence that some new research directions go towards climate and health. Medical science that teams up with climate science to learn more about how we can address and how we can understand the challenges for which parts of the society that come along with climate change and their local impacts. Living in the city, for example, is different from living in a forest. Drought goes directly to the resource of water. We know how important water is. Ask our colleagues in Spain what they tell us about the water crisis. It's a regional crisis, you could say, but it will transcend from regional to regional, over-regional, many countries, hemispheric perhaps, and so the resource water is a resource that people start disputing about. Start perhaps also wars about. Sea level rise. This is a no-brainer. If sea level rises, land becomes less, land is precious, land is perhaps in cities. In fact, hundreds of millions of people live very close to the ocean. If sea level rises, on top of the sea level rise, extreme events that will contaminate, threaten the resource of land. And finally, land use. Just give you 4 examples, the list could go on. Land use and climate change compounded will impact the resource of biodiversity. Biodiversity, the source of ecosystem services, not priced in classical economic models when they tell us how expensive the transformation will be, and therefore impossible. Let me close by a final quote by the distinguished first Nobel laureate in environmental science. There have been 2 more of the science Nobel laureates in our field, and that is for climate detection and climate modeling and understanding complex systems. That was in 2021, the Nobel Prize of Physics for climate modeling. But going back to Paul Crutzen, who anticipated all of that in 1995 with his Nobel Prize for Chemistry, in that article where he presented the concept of the Anthropocene, he said, and I think this should be a message to all of us today, an exciting but also difficult and daunting task lies ahead of the global research and engineering community to guide mankind towards global sustainable environmental management. I couldn't add more. Thank you very much.
Thank you for this marvelous talk, and it was extremely interesting for all of us, and I really am sorry that politicians didn't hear you today, and the decision makers. We have time for a few short questions. Excuse me, I'm sorry. Yes, please. Can we give the microphone, please?
Thank you, Thomas, for such a comprehensive presentation and view, much of it that you yourself worked along this way. So it's first-hand, really much of what you said. I want you to concentrate on one thing. September 2013 in Stockholm. Because I think it's very important what you just kind of went in passing. Very often you see out many people, even many scientists, they say, well, in the IPCC, you know, that the scientists that we are there or we have been there, that we kind of do not defend the case. And I think we do. And this was a very good example. People don't know, probably, I don't know if someone else was there present, I haven't seen anyone, but maybe give us some details of exactly what went on and how courageously the scientists really defended their position. It was not the first time, but this was a very critical one because of the implications that it had. If you could elaborate a little bit, and I think now is sufficient, it's 10 years ago, so probably we can disclose a little bit of the discussions we have, can't we?
Should I respond?
Yes, please.
Right away. Well, thank you very much for that question, and I very vividly remember how we were together at this meeting, together with a great team of scientists who were the authors of that report and of that summary for policymakers, and helped together with the Bureau and the co-chairs to actually defend it. And I can confirm what you just said. We took every measure to defend it with the best scientific arguments that we had. And just to give you a little anecdote, that one country that was not really happy about the global carbon budget fought until 4 o'clock in the morning. We had to sit up there. I had to chair that meeting with all the delegates. They became fewer and fewer as the hours went by in the evening. But at about 1 o'clock in the morning, I was already opening my second bar of Swiss chocolate to keep enough energy. That country changed the negotiation team. At 1 o'clock, a new team of fresh people came in, fresh negotiators, and what surprised me most is that it was a seamless passing of the baton. So they came in with new strengths, but in the end, it was the scientific arguments with the many voices of very well-respected colleagues who I gave the floor strategically and in a very well-concerted manner that actually convinced that one country that they have to go home and say, well, we did all we could, but in the end we failed because the science was stronger. And I think there are many examples like that. Let me add one most important point, and that goes really back to 1988. One name I have not mentioned, that's the name of Bert Pauline, a close colleague of and mentor of Paul Crutzen, in fact, who was the inventor of the Intergovernmental Panel on Climate Change, a Swedish colleague I had the privilege to meet several times, and I really admired him, how he could bridge the gap between the complex science, he was specialized in understanding the carbon cycle, and leading in a very smart way the politicians to the consensus that was necessary in 1990, in a time when scientists nor policymakers were used to the concept of a scientific assessment that was co-produced by the countries. That's another important element.
I can allow for just one short, brief question because time is going fast. So we have a question at the end of this room.
So maybe a very short question, hopefully short answer. So first, thank you for this enlightening talk. I'm a microbiologist coming from Israel. So I'm being asked, studying the carbon cycle, methane emissions, etc. So I've been asked more than once, and you mentioned the deflection point in the non-linear models. Where does the shit hits the fan? Or is there a ballpark where we come into a point with no return? And I know that there is a lot of discussion about it, but just a number.
Yeah, well, if you ask me, is there a point of no return for the entire planet in the sense that we slide into a hothouse climate, and that has been used by some of our colleagues, I would say no. These are interesting thought experiments, but aren't really based on sound physical science. So there is no runaway greenhouse effect in that sense that we've been taught that existed in the planet Venus, for example. We did early experiments with climate models to see whether the outgassing of CO2 in a warming ocean would actually accelerate such a tipping point, and it didn't pan out. So I think for global scale points of no return, I don't think that exists, but for regional scale points of no return, for example, tipping points in the mass of the Greenland ice sheet, I'm very much convinced that they exist. Are they at 2 degrees Celsius, global mean warming? Are they at 2.5 or 3? We're not in a position to tell you that at this moment, because the models are insufficient to quantify that tipping point, although we understand all the processes that lead to it.
Thank you.
It's good we have some time constraints. we cannot allow for longer discussion, but the good point is that Thomas will stay with us during the debate, and I think some of the questions can can be asked later on. So now please stay, because we don't have a break. So you can come back to the stage. But this discussion will be moderated by Aleksandra Kardaś from Foundation for Climate Education. Just let me say a few words about her, because it will be not easy for her to talk about herself. She has PhD in physics, which was conferred at Warsaw University. But now Aleksandra is a very well-known popularizer of science in Poland, and I would say of climate science mostly. She wrote a book on water. Water is one of the issues that we will suffer most, not only in Spain, but also, for example, in Poland. It will be a huge problem. She also was a co-author of 2 other books on climate change, and is present and in media very often. So, Aleksandra, please, floor is yours, and you can introduce the rest of the participants.
Thank you. So I would like to invite Thomas Stocker again to the podium, please, because we are indeed going to have him here during our discussion. So I don't have to introduce him because you have already had a very long introduction. But I would also like to invite Professor Helene de Koning to join us here. Professor de Koning represents Eindhoven University of Technology. She specializes in socio-technical innovation and climate change, and has been involved in the IPCC assessment and special report processes on many stages since 2017. Her research is focused on the role of innovation and technology in the international climate negotiations, on the policy for making energy-intensive industry climate neutral, and on the viability and societal dynamics of new technologies for 1.5-degree mitigation pathways. So very glad to have you here. And next, I would like to invite Dr. George Kroldulai from the Center for Ecological Research, Hungarian Academy of Sciences, and Pitfish Lurant Research Network, Budapest. Dr. Kroldulai is a senior research fellow at the Institute of Ecology and Botany. His research focuses on climate change effects on land use, vegetation dynamics, and effects of extreme weather on vegetation and landscape. Very happy to have you here. And last, but certainly not least, I have the honor to welcome Professor Didier Roux. I hope he's here. Yes, thank you. Professor Roux is the member of the Academy of the Sciences in Paris. He is a delegate for scientific information and communication. He is a former Chief Research and Development and Innovation Officer of Saint-Gobain and former Director of the Paul Pascal Research Center. His research focuses in the fields of physical chemistry, material sciences, and nanomaterials. He has vast experience in R&D and science-industry relations, so I'm happy you will give us some thoughts about R&D and industry relations on climate change. As we have heard just a couple minutes ago in Professor Stocker's lecture, global warming reaches levels not seen in 30 million years, and its speed is unheard of. If we do not act promptly on this problem, we must seriously take into account the possibility that the global mean temperature exceeds 3 or even 4 degrees relative to pre-industrial. The bigger the warming, the larger the risk of unpleasant surprises. Positive climate feedbacks may kick in and may lead to crossing more and more tipping points, as we heard in the lecture. And eventually, even a planetary threshold. We may be pushed in the direction of a total new climate, even if it's not a runaway climate greenhouse effect. It still can mean some very unpleasant consequences. We can experience irreversible changes on Earth, and all this may have serious repercussions, such as economic crisis, hunger, emergence of conflicts. Therefore, it seems prudent and even urgent to strengthen our efforts in preventing this from happening. The Paris Agreement has given us a specific target, keeping the global temperature below the threshold of 1.5 degrees above the pre-industrial norm. And the IPCC special report from 2018, mentioned here, has shown that every bit of warming above that threshold significantly increases climate risks. So to concentrate our discussion a little bit, I would like to start by asking Professor de Koning, can we still limit global warming to this 1.5 threshold, and maybe what needs to be done for us to achieve it?
Yeah, thanks. Yeah? Okay, great. It's not working? Now it is working? I thought so. Thanks for that question. Yeah, I was a coordinating lead author in both the 1.5 degrees report and in the mitigation report of about a year ago of the IPCC. And both reports concern themselves with that question. The answer is that we are definitely not on track, but it is still possible to limit warming to 1.5 degrees by the end of this century. Although we need really unprecedented system transformations in order to make that happen. And with system transformations, I mean not a reduction measure here or there, a little bit of solar energy, or transforming our electricity system. It's transforming our energy systems, our land and ecosystems, our industrial systems, so how we make things, and our cities and infrastructure. And we need to transform those both to address climate change, because it's already happening, but also to get our CO2 emissions to net zero in 2050 globally, as Professor Stocker already mentioned. We've never known so much about how to make these system transitions happen. There's a lot of physical science, engineering, social science, even humanities scholars concerning themselves with this question, and we really know what can be done and which buttons to push. The main barriers are institutional, are the way we run our societies, and that's where I think the core of the answers are. So I really invite also the members here who are active in the social sciences to engage themselves with these questions. How do we change societies so rapidly that we can make them more sustainable and in line with 1.5 degrees?
Thank you. So maybe, Professor Stocker, maybe you can tell us what is the current diagnosis of our climate action progress? Are we on the track to 1.5? You said some thoughts about this in your lecture, but maybe you can reiterate and say it really clearly now. Are we on the track?
No, we are not. It's very clear we are not. All the indicators, and the ultimate indicator is the global mean emissions, the globally accumulated emissions of carbon dioxide, and they point upwards. The last year was again 0.1% higher than the previous year. This is, perhaps you could frame that as a positive message. It's sort of the first instance that the curve may be bent, but I told you about the percentage reductions that we need to achieve if we want to actually arrive at net zero. What you referred very cautiously is actually by the end of the century we may actually be at 2 degrees, and that means that we are now accepting several decades of temperatures that are actually temporarily exceed that limit of the Paris Agreement. It's called the so-called peak shaving, where through some other measures we may actually discuss here as well, I don't know, one keeps artificially the global mean temperature below that temperature limit, but we haven't really addressed the root problem. And so I think that is in fact itself a dangerous interference and therefore not compatible with Article 2 of the Framework Convention, which not only addresses the emissions of greenhouse gases, but also potentially geoengineering and other measures to modify the climate system.
Thank you. So, since, as we see, many of the climate change's effects are now unavoidable, it seems that prudent to combine or at least harmonize climate change mitigation and adaptation efforts. But is this feasible? In this matter, I would like to ask for comment first from Professor Kroll-Dulai. What is your perspective as a specialist in ecosystem research as well as land use and landscape problems? Can we combine adaptation and mitigation efforts so they work together?
Can you hear me? Okay. Yeah. Can you hear me now? And now, is it better? Thank you. So to start with, I would like to, ecosystems are very special players, so I would like to emphasize two things. The first, that just by their existence, their functioning, they fix carbon dioxide, which means they are friends, they are allies in this fight, and we should, without them, we would be an even bigger problem. So this is first thing. The second one, that they have their an intrinsic adaptive capacity, and this is because they already experienced variation in environment and climate. So whenever we think of mitigation, we should always consider ecosystems as friends. So how their weaknesses, their well-being, and so on. And also whenever we consider an adaptation, we should try to build on their intrinsic adaptive capacity. So, and back to your very question, if we can harmonize mitigation and adaptation. If I take the example of the issue where ecosystems have the highest potential, and this is afforestation, reforestation, forest plantation, you can do mitigation, you can optimize for mitigation. For example, if you choose the species which grows the fastest way, that this suggests it is the best for mitigation. But if you also include adaptation, you should probably choose the species which you can also fix carbon under a future climate. But probably the best way is to choose multiple species, because then you allow the system to adapt to a changing and probably to factors that we don't even see now. So this is just one example. The other is flood regulation, like that floodplains should be given back to rivers. This is what this is a topic which is out there for a long time, and this also can be an example when increasing wetlands means more carbon kept back or maintained, but it also help the adaptation by reducing the flood level and also providing water for the summer drought events. But the overall message here that whenever any kind of mitigation adaptation measures, we should try to think of ecosystems because they help us. So we should work in a way which also good for them, and also should build on and strengthen their adaptive capacity. They cannot solve everything for sure, but they are very important players.
Thank you. So I think we've already had some very important inputs for tomorrow's cluster number 3 on water and ecosystems. I understand from what you said that it is very important to also think about timescales, because if we want to remove much CO2 from the atmosphere, we would concentrate on one species, and if we want to have a long-term working ecosystem that will keep this carbon within itself and store it for decades, or ages, we need to concentrate on different aspects. So this is a very important aspect, and maybe just an example of issues that we have to think about when we are reconstructing the ecosystems, because much is said about restoring ecosystems and guarding them now, and how do we maybe engineer them a little bit. But I would also like to ask from a different perspective on the adaptation and mitigation correlations and how to harmonize these two aspects of climate action. Professor Roux, how can we work on this project simultaneously in other sectors like industry? Should we come with systematic approaches or regulations, or just trust that industry will let itself be guided by science? What is your experience?
Okay, so as we have seen and very well explained, we are far from doing what we should do to adapt to something like the Paris Agreement. 1.5 degree is probably already behind us. And just to take your number again, the year 2020, during the COVID, for me the impact on CO2 emission was of the order of 4 or 5%. And as you explained, we should be at 14% every year, 14% to reach the 1.5 target. So this is just outside any scope. Nevertheless, since the beginning, I guess the scientists started to alert the government 40 years ago, even more, and it took decades before the government started to act. And by the way, IPCC is a remarkable organization by itself. Nevertheless, it's only recently that the problem of global warming is more or less included in all government projects. I mean, basically today, it's not possible as a government to forget about the problem. Nevertheless, we don't do enough. And one thing is that very often the government, they think about the two tools they have to change the society. The two tools are either incentives or regulation. So they use incentives and they use regulation. But as we have seen, it's not enough. And the reason why it's not enough is that in most of the countries, the economy is free. And obviously, there is a coupling between the decision of the individual and what is prepared by the industry and sale and commercialized by the industry. And if you don't take that into account, it's extremely difficult to regulate the economy only with incentives and regulation. It's not enough. So somehow the industry has to be part of the game, and the economy has to be part of the game. And I will come back to that in the second question. At least what we can say today is that the target cannot be, and probably the 2 degrees is a more reasonable target, cannot be reached without the industry. And the industry is probably, and when I say the industry, it's not the industry, but the economy. Everything going from the industry to the consumer. And we have to find a way to couple a global objective of the society to the individual decision of each of us. And until we find this way, it will be extremely difficult to change in a profound way the economy of the countries.
Okay, but so we can already see the complexity of the problem, because you are talking about combining the vision of the enterprise about its development, further development, and the vision of the future development of humanity. And still within these efforts, we still have these two aspects of adaptation to climate change and mitigation to climate change. So can an industry think about these two challenges at the same time to harmonize them, or do we think that we have to guide them?
But you see, if you want to see the industry to adapt, it has to adapt to the consumer demand. And the industry knows very well what to do to adapt to the consumer demand. But if the consumer demand doesn't change, the industry will not change. Okay, they can change, obviously, let's say the energy they use, they can change, they can save, and it's what is done. But it's not enough. What has to change is, for example, in Europe, we have the problem, there is a problem of the energy and the problem of the car, of the transportation. As you know, the big emissions are coming from transportation, buildings, and all the rest. If you just take into consideration transportation and buildings, which are the two main reasons for emission of CO2, it's obviously a change which has to come from our own way of living, and also on the adaptation of the industry. That can do it. The decision of the Europe to go from thermic car to electric car is a good decision. But then all the electricity has to be produced CO2 free. Otherwise, for example, in Poland, in this country, having an electric car is certainly not a good choice, because I guess that the electrical energy is coming mainly from coal. So if you have such a system, having an electric car is even worse than having a regular car. So you have first to change the production of electricity before to change the transportation system. Or it has to be at least done at the same time. And this is a kind of complexity that has to be done.
Professor de Koning, you would like to comment on that?
Yeah, and maybe, I mean, you're right. This is a very complex issue, and it's the system transformations that I was talking about. They can only happen if all actors sort of act at the same time. But I think the government is next to industry, next to consumers, next to the financial sector, which makes sort of the rules of what is invested in, what kind of decisions are being made. The government is also a very important actor there, because people cannot change their behavior unless the infrastructure is in place and unless the incentives are put in the right place. So in order for individuals to change, the system needs to change. And in order for government to act, in our countries, government needs a public mandate, right? So the people have to vote for governments that actually make the right choices. In order for public to do that, and also for government to be able to do that, industry also has to lobby in a certain direction. And so far, not all industries are necessarily lobbying in the direction of climate-friendly decisions, and the same goes for the financial sector. So it's sort of a very chicken and egg problem, but then with various other different actors, not just chickens and eggs, but many more, and all they basically everybody has to jump at the same time in order to be able to pull that rug. So it's more complex than that. And I think also, I mean, if you look at, for example, the transportation sector, indeed mobility, right? Electric vehicles can make a huge difference. I think the only two countries, according to a study of colleagues of mine, that are with their current electricity mix, where actually electric vehicles are worse than gasoline vehicles, are indeed Poland and India. All other countries in the world, the electricity mix is already low CO2 enough for electric vehicles to make a positive difference. Those are the only two countries. And the electricity mix is changing rapidly, even in those two countries. So already in 2030, there's no question that electric vehicles are better. However, it's not a solution to change all our cars into electric cars. Right? The resource demands are just too big, and the societal consequences of those are also too big. At the same time, we need to do something about how we plan our cities, about whether we can maybe live without a car, whether we can reduce car demand in general, maybe half the amount of cars that are around and replace them with non-motorized transport, better public transport, and maybe a lower mobility demand. So, and that's what I mean with systemic changes, that we think differently about the systems that we live in, because only then these very rapid emission reductions that indeed we need can be achievable. And I'm actually quite optimistic about that, or I would say hopeful, because optimistic as a climate researcher is sort of, you have to be very optimistic if you want to. But I think, I mean, these transitions can go more quickly than you think, right? With solar electricity, with wind electricity, we've seen very rapid changes. I mean, rapid cost reductions over just a couple of years' time that really not many people saw coming. And it was a combination of different factors that conspired to make that happen. And if we could look at the dynamics of systems and see where the intervention points are to speed up those system transitions, then actually we do stand a chance to still limit warming to 1.5. Maybe we'll have a little bit of overshoot, but I think it could still happen.
Professor Stocker, you would like to comment?
Yeah, I just want to come back to the statement regarding the consumer demand. The consumer demand, I believe, does not come out of the blue. Consumer demands are created by those who want to sell a specific product. And if I just give you an example of the consumer demand of cars, if you look at the typical car advertisement, it's for big, powerful, and fast cars. I've never seen an advertisement in the last 5 years for a small, smart, low-consuming car. It's just not yet a thing that is being created in the consumer demand. And I think that needs to change as well, because the consumer demand is not something that comes out of the blue. And for that reason, we need clever regulations that say, okay, here is a system that we want to nudge into this direction. Everybody please go into this direction. But within the regulation, the industry and the economy shall flourish, but you need regulations. And a final remark, essentially it's a pollution problem that we are dealing with. It's the global greenhouse gas pollution. If you look in the past, no pollution problem ever, be it local, regional, national, or global, has been solved with no regulation. And yet I hear in the global change problem, for years and years, oh, the individual must. Oh, if every individual does, then we solve it. What's wrong about regulations? Our societies are based on a framework of regulations. Let's have a regulation on greenhouse gas emissions.
But if I may, obviously regulation is absolutely necessary, and there is no doubt about that. But economists thought about that, and they came up with a solution which is not very simple to practice, but is very efficient, which is a CO2 taxes. And that's a decision which has to be taken by the government, and which is effectively very difficult to take. So what I think is that if you want to couple individual decision to the global objectives of CO2 reduction, the CO2 taxes is very efficient. And I just remind to everybody that the CO2 taxes is a tax of everything which emits CO2, and the money that you collect with the tax has two objectives. It's not to help the country to finalize their budget, it's to do two things. The first one, to have technology adaptation of every technology that will emit less CO2 than the old one. And the second is to help people, and especially the poorest people, to go through a transition period that will affect them more than the wealthy people. So I do believe that regulation is very important, but my point is that the most difficult decision to take is CO2 taxes. Nevertheless, it's probably the most efficient one compared to all other kind of regulation, which are very complex and sometimes have many drawbacks. So I do believe that one of the problems we have is the difficulty to have a government, and somehow to say that you have to vote, for people to vote for a government that will be ready to implement a CO2 tax. The only country in Europe which has done that since 1991 is Sweden, and I just remind you that the cost of 1 ton of CO2 in Sweden is 120 euro. It started at around 25 euro in 91. It went up regularly with time. It's 120 euro, which is barely what you need if you want to reach your objective to a CO2 taxes. Even so, the CO2 taxes doesn't exist in France, or it's at 20 euro per ton. So we had a way to adapt, both in our investment, but also with the R&D. I was in charge of the R&D, and our R&D program took into account the fact that the cost of the CO2 could be 100 or 150 euro, and we had program to develop technology taking into account the cost of the CO2.
Well, I see that we are having already emerging competing interests, and one of the fields in which we often have competing interests is actually the landscape, the land use and ecosystems relationships. So I would maybe give the floor for a moment to Dr. Krell-Dulai and ask whether you think that while discussing environmental protection, we have voices concentrating on different aspects of climate change, biodiversity, plastic or chemical pollution, or as you said, mitigation versus adaptation, even this introduces other different requirements on rebuilding an ecosystem. Do you feel that at least the scientists share a language and understanding of these topics, or do we have to work on our coordination within the scientific community as well?
I know? Yeah. So since I'm an ecologist, and ecologists for a long time had conflicts with other sectors that are using lands. Well, I wouldn't say conflict because we had no power, so it's more like a disagreement. So for a long time, ecologists saw that many other things should be done in a different way when managing the land. But I now feel that it's somewhat changing. Just in this very week, some of my colleagues have a joint field trip with foresters. So they are discussing possibilities for climate resilient forest management. This is something that was impossible 20 years ago because foresters didn't want to hear these things. They believe they know what to do. And this is also happening in Germany when there was this huge forest dieback in response to a combination of drought, the very warm years of 2018 and 19, coupled with bark beetle. So now in many parts of Germany, they are reconsidering forest management. And this is also happening, again, some other colleagues of mine are working together with the Council of Budapest on the green spaces within the city. So for a very long time, they were not open to these kind of discussions, but now they are open to change parks in a way which is better for pollinators, which needs lower input, but still there are more resilient grasslands. For sure, in a city, it is also dependent on whether people living in the city, if they accept that, and this goes back to this public awareness, if they think climate change in general is important. So something is changing. So these are the good examples, but on the other hand, there are also bad examples because the fact that climate change is in the climate change debate and mitigation issues, land use is so important. It also brings in new issues. For example, when people are considering where they should plant forests, areas which were never been forested landscape, but are suitable for forests. So there is a danger that that we might convert those areas. So there is a conflict, for example, or other conflict back to the issues of forestry in Germany, that they are considering bringing in new non-native species. So because the climate is changing, so there's also again a conflict to what extent we should try to maintain the native species, or we should bring in species which are not very far away, or bringing in species from North America. So overall, there are much more discussion going on between different disciplines, but on the other hand, new conflicts also emerge. But the general thing is that we should also consider, when we are thinking of managing the landscape, the surface of the whole Earth, we shouldn't try to come up with something which fits perfectly for a climate crisis, but thinking in more general and trying to generally increase resilience, the adaptive capacity of the systems.
Thank you. Professor de Koning, do you think that we have capacity to combine all those issues to make informed decisions in so many subjects and combine the adaptation and mitigation efforts and industry and landscapes and land use problems? Do you think that we have enough education and human skills to introduce such large systemic changes in a coherent way?
Yes. I think we have enough human skills and even enough capacity. I'm not sure if we're using it in the best way, frankly. Let me give one example from my own country, the Netherlands. Right, I'm a professor at a university. Right, so I spend my time on supervising PhD students who publish as many papers as possible. Right. I also spend my time on teaching, which is very important, and I spend my time on acquiring funding, with sometimes, only a 10% chance of getting it in my country. Competition is fierce. Lucky you. Thanks. So much time of people who actually know about what to do in these transitions is spent on competing with each other, right? And one of the things we're saying in these IPCC reports, coming again from the social sciences, is that we need everybody to collaborate. We need everybody to act roughly at the same time. But we as researchers, we're not changing our own systems. We are still competing with each other. And when I get my funding, my 10% chance, when I get it, I'm really happy because I can hire more PhD students who publish more papers, right? And in the Netherlands, they take 4 years to graduate. The first 2 years, they're fresh out of their masters, right? I'm not going to send them into society to help them with these transitions. They know nothing, right? And the second 2 years, they are panicking because they have to finish their 4 papers in order to graduate in time before the funding stops. That's our hamster wheel that we're running in, and the world is on fire, right? So that's how I sometimes feel as an academic in the system that we're in. We have lots of people who know. We know actually quite well what to do, but if a societal actor, if a province of the Netherlands asks me, can you help me with, combining the mobility and the industrial and the agricultural transition, and you actually use your knowledge, I have to say, no, sorry, I have to write a proposal. I have to, go through a paper of a student which then nobody reads. So I do feel that we have to look at ourselves as the research community, the academic community, how we can take our responsibility in a better way. And this is, I think, science education, also your field, and what Thomas has just been doing. Giving public talks is extremely important to increase climate literacy everywhere. That's definitely one of the tasks, but I think our responsibility extends further than that. We have to stand side by side with societal actors to make these system transitions happen.
So I think it would be maybe too much to ask the enterprises not to compete with each other, but instead cooperate. So with very low hope, I will ask Professor Roux, does he think it's possible? Or maybe if it's not possible to make the enterprises to work with each other, then maybe we can make some changes in the way that science cooperates with the industry, so we can maybe transfer our knowledge a little bit faster to the industry to make the climate action more efficient.
But again, in fact, the industry is much more efficient to adapt to a constraint than the basic society. So if the constraint is there, the industry will adapt. And by the way, I know very well both worlds, the academic world and the industrial world. There is much less competition within a company than within the academic world. I don't know anymore. The most competitive world that I know is really the academic world, and you described it very well. So I was very surprised to discover in the industry, they compete between industries, but within the industry, one industry, in fact, people are working much more together to an objective which is well defined than in the academic world. But okay,
so we need to give you to give the industry a straight line sort of target, to something that they can adapt to.
But let's take the example of the cars in Europe, which is, I think, a good example. Right now, the automotive industry is going through a tremendous change because of the regulation which has changed and which basically gives them as a target to stop to build classical cars in 2035 and just have electrical cars. And you will see effectively commercials very soon where people will say not powerful and so on, but going longer. Instead of 400, it will be 500 kilometers and so on. And then this will be effectively a commercial that will emphasize something lighter, something which will be smaller, because that's the only way to go longer. So this is just an example of how you adapt to a demand. And the demand is coming from the fact that there will be effectively a regulation that will just stop building electric cars. The only thing that I wanted to say is that we have to expect that at this time, all the electricity in Europe will be carbon-free. Otherwise, we'll be in a big trouble. That's one point.
Yes,
but industry will adapt.
Can I ask a question about that? Because in the latest Fit for 55 package, right, the ETS actually prescribes that from 2040 onwards, no new carbon credits will be given out.
I thought it was 35, no? It's 40?
No, 2040, the emission trading scheme for heavy industry and for... This is in 17 years from now. You know, in the chemical industry, this is 2 turnarounds. Right? I don't see industry lining up for that at all. And I work a lot with the chemical...
Which industry?
The chemical industry, the refining industry, the steel industry. They are really, I mean, 0 credits from 2040, right? And carbon dioxide removal is not yet allowed in the emission trading scheme. So I'm wondering why are they not acting like
Let me just answer with the example of the energy in general. What we would like to have is in Europe and more or less all over the world, a change from energy which is highly emitting CO2. Basically, it's something like 70% of the energy in the world is more or less using fossil energy today, 70%. We would like to have something that will be close to 0 in 20 years from now. When you look at the past, the time it takes to change an energy system at the level of a country to another one, it's more of the order of magnitude is more like 40, 50 years. So if you look at in the time how long it takes to go from one type of energy to the other, it's basically 40, 50 years. So going from today, 70% of the energy of the planet coming from CO2 emission, with CO2 emission coming from fossil energy to 0 is a huge and very ambitious objective. I don't say it's impossible. I just say it will probably take more time than 20 years, and we have to be realistic. If we want something like that, we have to do much more than what we have to do, what we are doing now. It's not saying that industry is not adapting in this case, because the energy is really something which is linked to the government. It's really the decision of the government which has to be much more ambitious than what it is now if we want something like that. We have just to be realistic. You cannot ask the industry to do it. It has to be at the level of a government in terms of the energy. And then the rest will...
That's what I was asking, right?
Yeah, but... no, I think we will not be, even in Europe, will not be 0. Think about Poland. How Poland can adapt in 20 years to stop using coal and gas. Is it possible?
Yeah, it's possible by a very radical change agenda. Yeah.
Okay. Is it something which is right now done to go to? No. So, you see.
I would like to ask also for a comment from Professor Gerald, because we spoke about the timescales in mobility or in energy transition, but we also have to introduce many changes in land use, agriculture, etc. And can you give us a feeling what timescales are necessary to see a change in this sector?
You can hear me now. it needs a long time. Well, agriculture can change fast, and it has a huge adaptive capacity. If the farmers cannot don't have harvest for a few years, they simply shift in crop. So agriculture can shift quite fast. Forestry is a very different thing. Like, and actually, it's an issue. What kind of trees you should plant today? Should it fit the climate today, or the projected climate in 20 years or 50 years? So this is why one suggestion is that you should plant multiple tree species, because it's not only climate, it's not only the direct effects of climate, but also you don't know what kind of pests will arrive from Asia or North America to Germany, or the other way around. It's two-way, or there are multiple ways. So just generally increase resilience. So forestry is a big issue, but still, again, back what I already suggested, that is also a problem that people who always want, or foresters who believe they should grow species from South America or Australia, now they always use this argument to bring in non-native species without investigating what the actual adaptive capacity of the species that are already here. Or once I have to bring a species, I probably shouldn't bring it from Asia, but from Southern Europe, which kind of mimicking the natural range distribution, kind of like an assisted colonization. A species range has changed after the Ice Age. We can kind of, but again, this is the process of building on the processes that would happen anyway in nature, and assisting it by kind of moving species that grow in the Balkans Peninsula. Probably those are the species that should be planted in Hungary, and so on. But the examples show that this might work better than bringing in very different species.
Okay, thank you. And I think I will open the floor for questions. So if you have any questions, yes, here at the third row, someone has the microphone, please. Do we have an assistance? Thank you.
Yes, thank you. Well, my question is to Professor Stoker. It was very interesting, your lecture. From what you said in the panel, I wonder if you were also thinking of mentioning something that Paul Crutzen contributed to science, and that is SAI geoengineering. So you mentioned temperature peak shaving as through countervailing climate intervention. And this SAI geoengineering, I mean stratospheric aerosol injection geoengineering, is being, there are many papers, I mean, being published, and of course it's controversial. So I'm wondering what's your opinion on this contribution of Paul Crutzen, and if this is something that can be considered as a way of temperature peak shaving. It's not to have very high temperatures above 2 degrees Celsius. Thank you.
Thank you very much for this question. Well, Paul Crutzen came onto this through his research in the 70s on nuclear winter. And he was the person who actually alerted humankind how dangerous a nuclear winter could be by global mean temperatures dropping for several years by about 40 degrees Celsius. Life would be destroyed on this planet, and that was his contribution there. I think in the following years, when he suggested in one of his papers, geoengineering, he was of the opinion that humankind would actually be able to carry out a controlled experiment. My point of view is that as a humankind, as people who look at the global governance, we have no positive record of a successful experiment at a global level. So I have no trust that a global governance could actually be implemented so as to wisely carry out in a controlled manner climate intervention as proposed. That it may actually help reduce temperature, global mean temperature, that is a fact that comes out of climate models. And the climate models, you can build a trajectory of emissions that would actually shave that peak. But that requires global governance. It requires also that humanity is actually serious about mitigation, is serious about a transition to non-fossil energy. And I doubt that. If you invest a lot of money to keep the temperature below 2 degrees Celsius, there is no motivation, there is no push to actually transform and go away from fossil fuels. And so my fear is in all that discussion where I realize increasing enthusiasm, even of highly respected scientists, that this is an option, even an emergency option to save lives. That's sort of the line of argument. I fear that there will be no reduction in emissions of carbon dioxide and other greenhouse gases because there is no longer a motivation for it. We keep the temperature at that level instituted in the Paris Agreement. And that constitutes an enormous commitment of danger for the entire globe. I usually give an example of a spring that you charge increasingly. The carbon dioxide concentrations go up, the temperature remains at 2 degrees warmer than pre-industrial. It's like a spring that you load. Now our future generations may say, we've got enough of this sulfur injection in the stratosphere. We don't want to do that anymore. And then you have the termination problem. A very well-known problem that exists as soon as you go into that commitment and ignore the reduction of emissions. Termination problem means that at that point you terminate the intervention, you will have a warming of 2, 3, 4 degrees Celsius within a few decades. It's like a relaxation of the system to the greenhouse gas concentrations that are there, and the temperature is not yet there. So we very much know how dangerous that could be, and so I would warn everybody of the illusion that we are able to basically manage ourselves towards climate stabilization by not addressing the root problem.
Probably I can add to this. Tapio Schneider at Caltech is a very clever atmospheric scientist modeler. And what they find in those new models they're creating is if you go too high in CO2 at 600 to 800 ppm, there are other thresholds where you lose the stratocumulus clouds of the tropics, for example. And it would just double up the man-made effect. This is what we call in also paleoclimate a runaway heating. I've met Paul Crutzen basically until he died in our institute. He would come once a week until he really couldn't come anymore. And he said the fiddling with the atmosphere is the only really bad idea he had. So he completely withdrew from that idea. So that's probably the late Paul Crutzen. That's the one idea. It was very intelligent of his to do the nuclear test, but fiddling with the atmosphere is something he really regretted he proposed that. But the one point I had was with Didier. We write since years and years, our economists, on the use of CO2 pricing. I'm all with you. It's probably more common. Now in 2023, 8 years after the Paris Climate Agreement, we have a global CO2 price of negative $150, right? So Sweden, and what we need is something between $100 and $150 positive as a real price. But the subsidies on fossil energy resource, particularly coal, brings us a price to negative 150. That's how far away we are in the real world from very often what we think would be important and where we stand.
Yeah, also on the question of, well, you call it geoengineering, maybe I can comment a little bit on what the most recent IPCC reports said on that, because it was partly in my chapter. Well, first of all, we're in IPCC completely avoiding the term geoengineering, because we think it's a very confusing term. It's been used for both carbon dioxide removals, right? So the net removal of CO2 from the atmosphere, and for solar radiation modification, the response that Paul Crutzen indeed published on in 2000 and indeed later regretted. I still think, I knew him a little bit as well, and I still think he published it mainly to wake everybody up, like see how crazy we've become, that we've gotten so far into this that we're, yeah, but maybe it was not that. Carbon dioxide removal is absolutely necessary, right? We cannot do without, if we want to be net zero CO2, and especially climate neutral, so net zero, all greenhouse gases, we need carbon dioxide removal of some form. There's a whole list of options there, some more permanent, others less permanent, but in general, they are either very land intensive, very energy intensive, or both. So that's sort of the sort of general rule. So and the potential in Europe and globally is limited. So the thing we need to do is rely on it as little as we can. And then SRM indeed is, the literature on it is growing, and I share Thomas's concern very much that this seems to be something that has growing funding. Scientific careers are being built on it. More papers are being published. More proposals accepted, more PhD students, more space in IPCC reports allocated to it because there's more literature, so you have to do something. So it's starting to become part of the mainstream discussion on climate change. I think we're on a slippery slope here. And I very much agree, I'm an atmospheric chemist by background, I very much agree that this is besides the termination shock, but besides the moral hazard of it sort of disincentivized, we have ocean acidification, which is not solved. And we actually don't know what, 30 years of sulfur injections in the stratosphere are going to do with this stratosphere. I heard a respected colleague say, we're destroying the stratosphere. We just don't know what this is going to do. So a big caution, let's try to stay out of the SRM response and see how we can actually solve this problem with mitigation.
Szymon Malinowski, University of Warsaw. I had to add one thing to your comment, since there is the study of International Monetary Fund, which checked for the fossil fuel subsidies all over the world. And, subsidies to fossil fuels are about 6.8% of global product and are increasing. So it seems that our, ability to address the problem in terms of regulations is strictly limited. And the second problem is the following, that they are not direct subsidies mostly they are indirect subsidies, which are designed to help poor people. So there is something very wrong in a system. We try to deal with fossil fuel emissions, since in the biggest I would say, element of the global product, subsidies to fossil fuels. And on the one hand side, we are fighting with, emissions, and on the other hand, we are pushing a lot of coal.
Two questions in the last row, but please, Dr. Koning.
Yeah, so the subsidy issue is a very complicated one. What do you count as subsidies, right? And if you help poor people pay their energy bills, right, it's a subsidy. It's counted as a subsidy. If you don't tax companies as much as consumers on energy, it's counted as a subsidy. So I agree totally. The amount is way too big, but there are very different ways of calculating what is a subsidy, and the conclusion is also very different in numerical terms. Doesn't mean that we shouldn't do something about it, but it is very, very clear that the method how you calculate it and how you define it matters a lot. I think the discussion is really about the financial system. The IPCC Working Group 3 report concluded that there's still more investment flows going into fossil fuels than into adaptation and mitigation combined globally. So the financial system at the moment is making consistently the wrong decision in terms of climate change, right? I talk to people from the financial system a lot, and they say, well, one of the reasons is how we assess risk. We assess risk preferably by historical data on technologies, so the technology risk, right? And we have way more data on fossil fuel projects than on renewable projects, right? So we know much better how they perform. The certainty is bigger, the uncertainty is reduced. On climate change, right, climate risks, we assess our risks based on the climate of the past. We have no methods to assess the risk on the climate of the future. So somebody compared it to, we're actually navigating our car by looking in the rear view mirror. That's how the financial system assesses the risk. So something needs to change there more structurally in order for the right decisions to be taken. And there's different financial actors that have a role in that. The central banks, the regulators, commercial banks, but also the project developers. Again, that's a complex system in itself with different actors that have to act in consortium. But it's that's definitely one of the key things that we need to look at, also as a research community, I think.
I think we can discuss it a little more tomorrow during our session on response by business and politics. And now, please.
Thank you. Can you hear me? Yeah. I'm Fiona Regan from Dublin, a fellow academic actually, and equally can completely relate, but delighted to escape to this fantastic discussion for 2 days. I agree regulation is critical, and it's really nice to hear reference to the Montreal Protocol to see that something has worked. And I agree also that regulation will require systemic change. Coming from Ireland, agriculture is a really important industry. And what I find is that while we have this really important agreement to reduce carbon dioxide emissions and greenhouse gas emissions, what we have are competing legislation within Europe, at least. Agriculture and environment are completely at odds. We had Food Harvest 2020, for example, which incentivized Irish dairy producers to double their dairy production. You can imagine what that has done to emissions and to water quality. So I suppose what my question is, how can we achieve this regulatory result if we have these competing legislative instruments that are so important in Europe, but they are not on the same plane? Thank you.
Please.
Can you hear me? No? Yeah. I'm not very familiar with these subsidy systems, but we also discussed how responsive different sectors are. And I think what you have just mentioned, that in agriculture, the subsidies are very important. So which means once there was a very clear political decision up up there, it would be very easy to change the system. Well, of course, you need different machinery if you have different crops, but in a sector which is so much dependent on subsidies, so the farmers just watch how it changes and they follow. I think there are good opportunity, but sure, I agree, it has to be clear, and if there are opposite subsidy systems, I don't know the details, then it's difficult, but in theory, I think it would be easier than in many other sectors. But I may be wrong. Cherry tree, it's more difficult than corn because it's a long living, but still. But this is the only thing I can add.
Yeah, so I'm sorry to take the floor again. I feel like I'm talking a lot, but I think the food system transition is also extremely important. I mean, globally, we're about 75% of the world's surface used for agriculture is used for meat and dairy production. 75%. Right? Imagine if we could halve sort of that consumption. How much space would be freed up for nature or for biofuels or whatever you want to spend it on, right? I mean, it's an enormous amount. So our animal protein consumption essentially is part of the problem here. So, and that there's basically no vision of how a European agricultural system and food system should look like or could look like, and how to get there. I think that's a huge problem because the farmers also don't know how to act, right? They get the wrong incentives continuously, also in my own country, and they're currently taking to the streets, sort of in a similar way as the yellow vests in France, really blocking things because they feel so unjustly treated in the past by the incentives they've been given. So I think it really points to, in all these sectors, in all these systems, that we need much more attention to the justice. You mentioned it as well, and Paul Crutzen mentioned it as well, the justice in the transitions, meaning justness in distributional outcomes, right? And who gets the cost, the benefits, where's the jobs created, where are they lost? In procedural justice, so are people are taking part in the decisions, but also restorative justice. So has there been injustice in the past, and can we repair that by taking actions for the transitions of the future? I think that's really important because many people feel treated unfairly. This is fueling populism everywhere, and this again is blocking our ability to respond to this climate change challenge.
Thank you, and we had questions at the back. Raz.
I just wanted to bring another aspect that was not in the discussion and is related to the ecology aspects. I think Thomas, in his beautiful review, indicated that we are emitting today about 10 gigaton of carbon every year to the atmosphere, and the biosphere is actually absorbing 30% of this, almost 3 gigaton. And we are not keeping the biosphere. We are talking, you mentioned forestation, but in fact, we are deforesting the biosphere with an equivalent about 1 to 2 gigaton every year. And the cheapest way to have an impact on the carbon emission is to just avoid this deforestation. And we are gaining gigatons of carbon in reduced emission. I think it is something that has to be discussed also.
Any comments?
Yeah, I couldn't agree more. I mean, if people ask me, how can we get the first 10% of emissions reductions now? It's stop deforestation. Stop it completely, and you will have secondary benefits of biodiversity conservation.
There is another way that everybody knows, but which is very difficult to implement, is to spend less energy in buildings. Because buildings in Europe is 42% of the energy consumption and 25-27% of CO2 emission. And renewing old buildings is something that it's difficult to do, but it doesn't hurt the way we live, and we increase the comfort and so on. But nevertheless, even so it has been known 20, 30 years ago, the result today in Europe is not so much, depending on the country. There are countries which are more advanced. Germany is rather good, but the south is rather bad. But this is a target where you can save a lot of energy, you can save a lot of CO2 emission, and this will impact positively the life of everybody. But nevertheless, it's very difficult to implement.
I mean, the point is we need all of that. There is no silver bullet. We need all of that.
Okay, I think we have time for one or two more questions, so please.
Thank you. Just with regard to the previous question, tomorrow we have a discussion on agriculture. There is a lot of investments and attention from the EU towards this, let's say, food security versus gas emissions problem. So we can discuss it tomorrow, but scientists are actually working on solutions. But my question is, again, very short. What is the panel's take on carbon credits with regard to, let's say, incentives? Most of them are now voluntary. Does it work or not? And what is the future of carbon credits?
Should I? Yeah, so carbon credits come in very different forms, right? So I would say the most secure form of carbon credits is in the European emission trading scheme, right? Where there's a ceiling over Europe by law. You know, there's very little fraud in the system. CO2 emissions have to go to zero in 2040. It covers the electricity system and large industry in Europe, including the embodied emissions in buildings, by the way, which are produced by the cement industry, etc., which are under the ETS. So that's a super important instrument. It has been sort of almost dead during the financial crisis, right? When prices collapsed because demand for energy collapsed and for materials. But right now they're around $100 or euro per ton CO2, so quite high. And yeah, so that's really giving an incentive for at least incremental innovation. It's still not giving, you know, a carbon price is not building hydrogen pipelines or train lines, right? So we need to be clear, you still need transformational policies for that and public investments, but it can play a big role. Regarding the voluntary market, I think it's all over the place. Really, I mean, there's really, really bad projects and there's really good ones where, you know, more idealistically minded organizations are trying to really be very additional. The carbon market under the Kyoto Protocol, the Clean Development Mechanism, I researched that 20 years ago or something. That was a multi-billion-dollar market globally, but that really collapsed on that the rules just weren't strict enough. And many projects were not additional, so did not lead to real emission reduction. So they're trying to reinvent that under the Paris Agreement in the Article 6 discussions. Not sure where that's going at the moment, but I hear they risk, you know, making the same mistakes as in the Clean Development Mechanism. For now, those are not allowed into the ETS in Europe. Exactly for those reasons. And for the rest, all over the world, new emission trading schemes are being installed. South Korea has one. China is starting to develop one. Some states in the US and in provinces in Canada have one. So we're seeing pricing schemes, either taxation or emission trading, coming up in different places. I think that's positive news because it's one of the instruments that's in the policy mix. It cannot be the only instrument, but it's definitely an important one.
Thank you, and I think it's time to end our discussion. I think we have touched many topics from the main results from the IPCC report and the ways to mitigate or adapt to climate change using nature-based solutions and the possibilities that the industry gives us, the financial possibilities and the capacity of our societies, and all these subjects will be also introduced in tomorrow's discussions. So I hope we will use this occasion to discuss a little more on all those topics. I would like to thank our panelists, so maybe one more round of applause for Professor Stocker, Professor de Koning, Professor Cruel Dulai and Professor Hu, and now I will pass over to Ms. Anna Zyberg, Flutter Zyberg, and she will give us some logistic details for this evening.
Thank you very much, Dr. Kardash. Thank you for this wonderful panel discussion. We have just one more point on our agenda for today, and this is dinner. But before we take you for dinner, we would like to invite you also for a group picture. The first group picture will take place here in this room, and the second picture will take place on the staircase on our way to the buses that will await us in front of the building. So first, the picture will take place here in this area, and I would like to invite our presidents to stand in front row, and also to be joined by other presidents and the keynote speakers and the panel members in the front row, okay, next to the bouquet of flowers. And I would like to invite all of you to join me here on the podium. Yes, wonderful, thank you.